So this section, we're going to talk about the organizing and activating effects of hormones. So organizing effects of sex hormones, there's basically two different types of effects, but we'll find that there's not a super clean line between the two of them. But basically, the organizing effects of sex hormones, they occur at sensitive periods of development. A lot of the organizing effects happen before birth during prenatal development, but there's other organizing effects that happen at puberty. That period of adolescence and the teenage brain is like a really powerful time period. Um, these organizing effects of sex hormones will determine whether the brain and body will develop male or female characteristics. Whereas in contrast, the activating effects of sex hormones, they can occur at any time of life, and they temporarily activate a particular response. For examples in pregnancy and menstruation. We'll find out that testosterone has a major role in the sex drive. Also, it has a major role in aggression. So there's another activating effect that you could think of. A lot of times my students ask me, Amy, I've heard that you have different sex drives at different ages. What about that? So some of you know that when males are younger, they seem to have a higher sex drive, and as they age, it kind of decreases. Whereas women tend to have a different sex drive when they're younger than when they're older, and this may be the effect of the activating effects of sex hormones. And what's so cool about the activating effects of sex hormones is that it's kind of like just like the epigenetics that we learned about, that your behaviors can influence the hormones and their activating effects. Your environments can change the activating effects of sex hormones. Some really interesting information in the chapter about that. So, like I said, the distinction between activating and organizing effects of hormones is not absolute. Hormones early in life can exert temporary effects, and also during puberty, hormones can induce long lasting structural changes. So let's just make it super simple though. In general, as you're just kind of learning the basics of this organizing, just think of them like they're the builders, they're the organizer. They happen early in life or at the critical time period of the teenage brain, and they set things up. It's not going to change much. And then activating effects, they're going to happen later in life. They're active, and they can change a lot. So, these next few slides, when I first learned the next few slides that come on, I mean, it was just crazy for me to know that because I hadn't been taught it. But I think a lot of you have already been taught some of the information, so you might not be as like wowed by it as I was. Um, I didn't realize until I took a class like this that males and females all start with the same capacity to either be differentiated into being males or females. So we'll talk about Mullerian ducts and Wolffian ducts, and given the right circumstances, an XX chromosome can develop male genitalia and masculine features, and an XY chromosomes, given the right circumstances, can develop female characteristics and female genitalias. Here's just one like little side light before we get to that is hormones don't account for all biological differences between males and females. So your textbook talks about that. I always like to use the Jurassic Park example. For those of you that are Jurassic Park fans, you would know that all the dinosaurs on the island were female. And the line in the movie goes something to the effect of, we simply deprived them of the hormone during a critical period of development. And uh, the default mode for humans is female. But as your book talks about, that it's not completely true that, oh, everything's just going to be normal if these hormones are there. So there's more to it than just, If testosterone is present in the womb during the first trimester, then you get male genitals. And it's not as simple as saying, okay, if there's no testosterone in the womb, then you're going to develop female genitals. So here's like a sidelight from that. Hormones don't account for all the biological differences between males and females. So we're going to talk about some big, broad stuff on the next slide, but we need to remember these things. Genes on the X and Y chromosomes also produce sex differences. At least 3 genes on the Y chromosome are active in specific brain areas, and at least 1 gene on the X chromosome is active in only female brains. Okay, so that last slide, you don't have to know all of that, but I do think it's my responsibility to share with you that with regards that it's not as simple as this hormonal explanation that we're getting ready to go over. But here's the simplified version. Our sexual differentiation depends mostly on levels of testosterone during the first trimester for our genitals. For the second trimester, they found seems to be related to the hypothalamus and other brain areas. And then the third trimester these hormones seem to be more involved in male and female differences in the cortex portion of the brain. So the human sensitive period for genital formation occurs during the first trimester of pregnancy. So here's the picture that just leveled me when I was taking this class. So I was young, and of course I was trying to figure out sexuality, and I always wondered, how do males feel during sex versus how do females feel during sex, and are our experiences very similar? Are they really different? And so when the teacher taught us about this, that basically the same exact tissue is differentiated into either male genitals or female genitals. So for example, the head of a man's penis is the same tissue as a woman's clitoris. And I always talk about this in class, and I'm like, okay, gentlemen, so let's talk about the head of your penis, maybe between 1 and 2.5 inches in circumference, and the clitoris, by contrast, is definitely less than an inch, but it's the same amount of sensory receptors in there. And a lot of times people are thinking, oh, the clitoris is just this very small area, but what a lot of us don't know is that the clitoris is actually very large, and it goes way up inside of us. And in fact, what they think the G-spot is kind of stimulating the underneath portion of the clitoris. So the G-spot is found on the anterior wall of of the vagina, maybe the ventral wall, so it'd be the top part, and it's about an inch in, and they think there's some women that respond very strongly to that. Other women do not, but they think that somehow it is stimulating the clitoris. And then to know that the testes develop up inside of the abdomen, and then they drop down at about 7 months when the woman's in her 7th month of pregnancy, and that our ovaries are homologous, made of the same tissue as male testes, but ours don't drop down. So basically, what's so amazing is that this same tissue is just differentiated into the male genitalia and the female genitalia. So, like, for example, our labia is made of the same tissue as the man's scrotum. And when that was shared with me, it was just mind blowing, because I was like, oh, so we probably do have very similar sensitivity, and we probably do function very similarly because it's the same tissue, it's just differentiated differently. So now the next thing that I'm going to do is I'm going to show you a video talking about this, because we're going to segue into intersexuality. And this next video that I'm going to show you is an older video, but I feel like it shows everything that I want to share with you. So I looked for other ones, but I really like this one. So take a look at this before we go into intersexuality. What if something is not quite right, and these don't differentiate into completely male genitalia or female.
Begin with the same basic parts.
Most parents don't understand that the penis and the clitoris are the same organ, and that the outer labia are the same as the scrotum. We all start out the same way, and we have to understand that the body can make an error.
Until about 6 or 7 weeks after conception, fetal genitalia are identical in both boys and girls. Then, if the baby is a boy, a gene on the Y chromosome causes the gonads to develop into testes. If there is no Y chromosome, the gonads develop into ovaries. But the remaining steps are driven primarily by the embryo's sex hormones, not its chromosomes. At about 9 weeks, a male fetus begins to produce testosterone, which masculinizes the body. Without testosterone, the genitals maintain their feminine appearance. But there are variations at every step along the way, and some children are born with mixed sexual characteristics in what is called an intersexual birth.
That female baby has more male hormones than she should have, and suddenly her sexual organs develop more masculine, and they can look a slight enlargement of a clitoris or a clitoris that looks like a penis. I would like to bring to your attention today this 3-year-old boy who came to the doctor's attention as having no palpable testicles. It was soon realized that this little boy was not a little boy.
There are dozens of conditions that can cause intersexuality, and just as many physical variations.
Early 60s. So it could be somebody who has ovaries and testicles. It could be somebody who just has testicles but is not virilized enough so that the penis did not develop normally. It could be somebody who has both a vagina and something that looks like a penis. So there's all variations.
And it's not as rare as you might think. As many as 1 in every 2,000 children are born with ambiguous genitalia. Approximately 65,000 babies a year worldwide.
I was born in 1956. I was my parents' first child. And when I was born, I know now from having spoken to my mother that everyone in the delivery room fell silent. And it was clear that something was horribly wrong. And they wouldn't tell her what it was, and they wouldn't let her see me.
3 days went by while the doctors pondered the baby's ambiguous genitals.
And eventually they decided to label me a boy without having even looked carefully. If they had looked, they would have easily noticed that I had a uterus.
But to the doctors, the baby appeared to have a penis, and time was running out. The parents were demanding to see their baby.
And they told my parents that I had micropenis and undescended testes, and that there wasn't anything that they could do about it. And they sent my parents home.
The decision was made. The relieved parents named their new baby Charles, and life went on. But when Charlie was 18 months old, his parents, still uncomfortable with his unusual genitals, consulted a new specialist who admitted the toddler to the hospital for a sex determination. They started with a chromosome test. Chromosomes are bundles of genetic information that largely determine who and what we are. In a normal male, every cell in the body is XY. In a female, every cell is XX. Some people, including some intersexuals, have both, what is called a mosaic pattern. The tests revealed that Charlie's chromosomes were XX. Female.
You can't stop there. There's more to it.
People think that your sex chromosomes determine your sex, and it's not so.
There are XX males and there are XY females.
That, in many ways, override our genetic sex. For For example, if the fetus produces too much testosterone at a critical time in its sexual development, an XX female can appear masculine. Too little testosterone, or an inability to respond to it, can keep an XY male from virilizing, creating genitals that appear feminine. And as to how we feel about ourselves,